Hello, this is Mrs. Decker, and this is Objective 3E on finding the concentration of an unknown acid or base using titration. And titration is a laboratory technique that we will use that I will teach you how to do in this lesson. So first, we want to predict the products of the following acid-base reaction. So remember, when an acid and a base react together, one of the products is water, and then we're left with calcium and nitrate that will bond together. Calcium has a +2 charge, nitrogen has a -1 charge, so our formula is going to be CaNO3 2. So then the last step would be to make sure that the equation is balanced. So you would need to put a 2 there and a 2 there. Now we know that the acid, which is HNO3, would have a pH of lower than 7, and the base, which is CaOH2, would have a pH of greater than 7. If we were to mix the exact amount of each of these acids and bases together and the concentrations were exactly the same, all of the acid and base would be turned into water and calcium nitrate. Water, we know, should have a pH of exactly 7, and calcium nitrate also should have a pH of 7. It should also be a neutral product. So the pH of our products should be 7. They should be neutral. That's why an acid-base reaction is called a neutralization reaction. So now we want to talk about what titration is and some common vocabulary that's associated with titration. So titration is a laboratory method used for determining the concentration of an unknown acid or base in a neutralization reaction. For our case, we will have an unknown acid and we will know the concentration of the base. Okay? So the base will be our standard solution, which is the solution where the concentration is known. The equivalence point is the point during the titration when there are stoichiometrically equivalent amounts of acids and bases, what that means in simpler terms is the moles of the H+ ions are equal to the moles of the OH- concentrations. So this is exactly when the pH is equal to 7. The endpoint is the point at which the indicator changes color, which is also at the equivalence point. And you should be familiar with what an indicator is by now. It is a chemical compound that will change color and structure when exposed to certain conditions. The conditions that we're talking about in this reaction are when it goes from an acidic solution to a more basic solution. When it starts to get to a neutral point as we are titrating, you will see a very light pink color. Once the color goes dark pink, we have gone past the equivalence point, and now this solution has a basic pH. Now, as you are titrating, you could use some probe equipment to generate this titration curve for you. We will not be using that equipment. We will just be looking at the color changes to determine when our equivalence point has been reached. However, you should be familiar with what the titration curve looks like and be able to label some parts to it. So on the y-axis, we have pH, so it would go from 0 to 14, and on the x-axis, we have the volume of base added. So the equivalence point is right here at when pH is exactly 7. And when we have a high H+ concentration, that is when we are in acidic concentrations, which are pHs of less than 7. So down here is where the H+ concentration would be high. And then a high OH- concentration is where we would have high pHs and basic conditions. So high OH- concentration would be up here at the top of the curve. So to solve titration calculations, you need to know the concentration of either the acid or the base and the volumes of both the acid and the base used to get to the equivalence point. From that point, you can calculate the unknown concentration using solution stoichiometry. So our first example says, what is the concentration of HCl if 30 milliliters of 0.10 molar NaOH neutralizes 50 milliliters of HCl? So the first thing that we need to start with is a balanced chemical equation. So HCl is our acid and NaOH is our base. So we need to predict the products of the reaction, which will be water plus NaCl. Na is +1, Cl is -1, so that is a neutral formula. And because they are +1, -1, this equation is already balanced. So now we have the volume of HCl used, which is 50 milliliters. We know that we used 30 milliliters of NaOH, and we know the concentration of the NaOH is 0.1 molar. So the first thing that we need to do is use our molarity and our volume of NaOH and figure out how many moles are there. So we do 0.1 molar is equal to X over 0.03 liters, because remember, when we're using our molarity equals moles over liters equation, the volume needs to be in liters. So our moles of NaOH are 0.003 moles. Okay, and now we're going to use the mole ratio between NaOH and HCl to convert to moles of HCl. So we have 1 mole of NaOH to every 1 mole of HCl. So that gives us 0.003 moles of HCl. So now we have the moles of HCl and we have the volume of HCl that was used, so we can use those two values to calculate the molarity of the HCl. So our moles of HCl are 0.003 moles, and our volume of HCl that is used is 50 milliliters. We want to use 0.05 liters. So when we solve that, we get 0.06 molar HCl. So the concentration of the HCl was 0.06 molar. All right, so example number 2 says a 20 milliliter solution of SrOH2 is neutralized after 25 milliliters of standard 0.05 molar HCl is added. What is the concentration of SrOH2? So again, we need to start by writing our equation. We have HCl plus SrOH2. Our first product is going to be water, and then we're going to be left with SrCl2, because Sr is +2, Cl is -1. So our neutral compound is SrCl2. So this equation will need to be balanced. So we need to put a 2 in front of the HCl and a 2 in front of the H2O. So now we know we had 20 milliliters of our SrOH2 solution, and we used 25 milliliters of the HCl to neutralize that with a concentration of 0.05. So we have our concentration and our volume of the HCl, so we're going to use that to solve for moles of HCl. So 0.05 moles, molarity, equals X over 0.025 liters. So we get 0.00125 moles of HCl. So now we're going to use the mole ratio. So we have 2 moles of HCl for every 1 mole of SrOH2. So when we calculate that, we get 0.00061 0.625 moles of SrOH2. So then our last step is to use the moles of SrOH2 and divide by the volume of SrOH2 used, which is 0.02 liters, and that gives us a concentration of 0.031 molar SrOH2. Our third example problem says how many milliliters of 0.2 molar H3PO4 are needed to neutralize 55 milliliters of 0.1 molar solution of NaOH. So in this case, we have the concentration of our acid, and we want to know how many milliliters of that acid we would need to get to our equivalence point. So we want to start by writing our equation again, which is H3PO4 plus NaOH. One product is water. The other product is Na3PO4. So again, we need to balance. We would need a 3 there and a 3 there. Okay, so we know the concentration of our acid, and we know the volume of our base and the concentration of the base. So we want to start by solving for moles of NaOH. So we get 0.0055 moles of NaOH. Then we want to use our mole ratio, so 3 moles of NaOH on the bottom to every 1 mole of H3PO4. So we get 0.0018 moles of H3PO4. So now that we have moles of H3PO4, we are going to solve for volume of H3PO4 using the concentration, which is 0.20. So when we solve for volume, you would get 0.009 liters or 9 milliliters. So you would need 9 milliliters of the 0.2 molar H3PO4 to neutralize 55 milliliters of 0.1 molar NaOH. So this diagram gives you an idea of how we will set up titration. The device we will use up here is called a burette, and we will put our known concentration of sodium hydroxide in there. And it's not shown in the diagram, but there are measurements here on the burette, so you'll be able to figure out how much NaOH you are adding to your flask down here that is containing your HCl and your indicator, which is the phenolphthalein. So the burette is designed to be able to release whatever is in it very, very slowly. So you will learn that you will have to do this pretty slowly so that you don't pass your end point. So you will have the flask in your hand here, and you will be constantly swirling it as you add your NaOH, and then you will start to see some pink appear. Your end point is here where you reach a very, very pale pink color, and it stays there. If you get something that is dark pink and swirling will not make it get any lighter, you have gone too far, and you're going to need to do that titration trial again because you have too much NaOH in there. So on Google Classroom, I have posted the link for a video on how to titrate. I would like you to watch the video because it goes more thoroughly through the procedure of how to titrate. And once you have watched that video, there are some practice calculations for you to work on. So I will end this video with these memes for you. Let me know if you need some help.